Hey everyone, Tim here. Yeah, today we're going to be doing a bit of C programming, and we're going to have a go at a very cool single header file library called Sokol. So let's dive into it. So this is the GitHub page of the Sokol library, and we're going to be playing around with that today. So yeah, it's a very cool library. And one of the cool things about it is that it follows this style of libraries that are becoming quite common in C now. For good reason, because C, the dependency management in C can be quite difficult at times. Trying to install a library, compile it, whereas, follow this link here, but you can read up about the STB style of header files, and basically it's just a single header. So you just include that single file, and that's all you need to do to include the library. So you just include that, you just download the header and include that library, and yeah, so even though there's multiple header files here, each one is an individual library in its own sense. So you only just pick the ones that you want. In this case today, we're going to be using this so-called GFX, which is the main graphics library in this project. And so that's really all you need. But what that does allows you to draw in a cross-platform way, um, draw to a window or to a screen. And yeah, you can see here, this is the core libraries here. So it's a 3D API wrapper, and it wraps GL, which is OpenGL, WebGL, Metal, DirectX, to Microsoft's graphics renderings, and the web GPU. So you can sort of pick your platform, and you can write in a very platform independent way, and yeah, draw some graphics. But to draw graphics, you also need a window. So you need to create a window. And if you could just write the window in code in Windows, or you could write using Objective C and write create a Mac window, or Linux, you can open a GTK window, however you like to do it. But or you can use there's other windowing libraries, GLFW, which allows you to write a window in a cross-platform way. But this actually comes with a nice app framework wrapper, which is called Sokol app. So that will allow you to create a cross-platform window, and it's got some input, so you can read the input from the keyboard, and then from within that window, you can then you'd have your drawing context that you can draw to. There's some other libraries there that can also be useful, but we're just going to start off with these two for a start today. So yeah, let's get into it. So we'll jump back to our code editor. Let's make a folder for the Sokol library, or this is our demo app. So I'm just going to make a folder here called Sokol demo, and we'll jump into that. Today we're going to be using NeoVim as our code editor of choice. VI is I've got an alias for VI that goes to NeoVim. So we'll create a main.c file, and I like to put it in the source folder. Okay, so let's open up our main.c, and let's just create a very basic hello world just to get started. I think it's always good just to start off with a standard.i, a hello world, just to prove that you can compile. And we'll just start with absolute basic. So we're just going to start with bare minimum. We're just going to build it up as we go. So let's just say hello Sokol, and we'll create a new line, and we'll return from our main function. And let's I haven't spelled include correct here. Okay, that looks pretty good. So I've got no compile errors there. So we'll let's just open up our terminal here, and I'm using Clang as the compiler. But if you're this demo should work on any platform. So if you're on Windows, or you should be able to use any compiler. If you're on Linux, you should be able to use GCC. Most of these examples should work pretty much the same. So let me know in the comments if it doesn't work, or there's something that's not cross-platform that doesn't work in your case. But yeah, so we're using Clang today. I'm on a Mac. So the output file, we're just going to create a demo file, will be our executable, and our input file is going to be source main.c. So let's just give that a whirl, and looks like we compiled. We'll just ls in directory, we've got our demo. This is our executable file. You can see here that this is executable. So let's just run our executable and we've got hello Sokol. Okay, very cool. So just to make this a little bit simpler, I'm just going to make a make file. It'll just make our life a little bit easier. So when we have a make file, we actually have the target, which is the target file we're trying to create. So we're trying to create this demo executable. And then on the right-hand side of the target, we have the dependencies. So the demo executable will depend on main.c in the source folder. And then to create that file, we want to do the exact command that we just ran before, which is demo is our output and our input is going to be main.c. Okay, now when you create a make file, it's very important to make sure that this is a tab. So that's a tab character. My editor puts that there automatically when I hit tab, but just make sure that your editor's not replacing this with spaces, otherwise your make file will not be happy. Okay. All right, so we'll save that. Now we go back here. If we just hit make, yeah, there's nothing to do, but if we go make B, which will force the make, we've got our demo. So let's just remove our demo just to make sure this is all working. And we hit make and we get our output and we can run it. So I might actually just put a run as well, which will depend on demo. And we go like that. Let's see if that will work. There we go, that's very nice. Don't like how it puts that little, yeah, that's better. So when you put the @ symbol, make will actually echo out the command that you just ran. So if you put the @ symbol there at the front, we'll just silence it. So I just get the actual output from the program. Okay, so we can just say make run and we get hello Sokol. Very nice. So let's yeah, now the first step is to get this let's set up our app. So let's see if we can create a window. So we'll Sokol app. So what we want this file here. Okay. And yeah, this is the file we want. So the easiest way for me to get it is I'll just hit this raw and that will actually give us a URL. Okay, so from there, just go across to our shell and we can just wget that. Okay. Oops, what have I done here? I don't know what I've done there. There we go. So wget that URL and we can see we've got our file here. Okay, so what I'm going to do, just to have a little bit of organization, I'm going to have a dependency folder. And I think I'm just going to put that folder into our dependency. So this is just a place where I'm going to include this folder. Okay, so we've got that file now. So the first thing I'm going to do here, let's include that folder. So I want Sokol app.h. Now, first up, it says can't be found. One way we can solve that is just put the actual full path to it like that, and it still doesn't like it. See if our make file likes it. No, it still doesn't like it. It's obviously not searching for it. So what we actually just need to do is pass in here the I flag, which is the search path. Okay, so now it's telling us when we're looking for files, look in this directory for any includes. So the capital I for includes. We run make and then it works. Okay, beautiful. Now the problem is my editor still doesn't like that because it doesn't know about my make file. So the way I like to solve that is I actually create a little variable here called cflags. Okay, and I'm going to make this a cflag. Okay. And then here, I'm going to then include that cflag as an argument. Like so. Now that shouldn't change. That still works. But what I then do, on my GitHub, I've actually got this little library, this little repo that I've put together, just a lot of shortcuts that I've sort of started to put together. But on here, I've got a make file. I'm just going to steal a little snippet from here. Down the bottom is this compile flags. I'll explain what that is in a sec. So once I go back here, we'll just put this compile flags here. So what this does is we're generating a compile flag. So the I'm using clang D. Clang D looks for a compile flags.txt file, and it will use that as its file, as its C flags when it's doing the looking for errors in the source code. So all this does is outputs a little message saying we're generating the compile flags, and then echoes the compile flags and converts the tab characters into new lines, and then outputs it into the compile flags.txt. So let's just run that. So we'll just run make compile flags. Okay, and you can see there it's generated the compile flags. So we go back here and we can see now it's generated the compile flags, and it's just there's a -I depths. So I could have easily just created the compile flags file and then just manually added that there, but then you've got to maintain any flags you have, you've got to maintain in your compile flags and in your makefile, whereas now I can just add them to the makefile, regenerate the compile flags, and everything's kept up to date. So hopefully now, if all goes well, I come into my main file, I just hit save and it seems to regenerate the LSP, and I'm getting no errors. So yeah, it's all looking good so far. Right, so we've included the Sokol app. Now let's see if we can yeah, I think let's just start reading up about this Sokol app. So great thing about these signal header files, most of them are very self independent. So you know you can just they're self-documented, all the documents in the file, you know, the entire everything's in the file. So you can just sort of read through the file. So the first thing it says you need to define the Sokol implementation or Sokol app implementation. So we need to define that before we actually include the file. So let's just do that. Okay, so let's define Sokol implementation. And yeah, that looks like we're getting some errors now. So let's that's kind of what we wanted. So let's just make that and let's see, have a look at some of our errors. Right, so most of these errors here, so let's have a look. So this is, if you have a project Objective-C, this looks like Objective-C because I'm on a Mac. So I'm getting errors now with my Objective-C. So the problem with this is that I need to sort of include some of the Mac stuff to sort of so it can compile the Objective-C. So the way I figured out how to do this is back on the Sokol library. See if I can find it. There is a very cool example or project called Sokol GP, which is 2D graphics library. Now on here, they have a makefile, and the makefile's got some very cool stuff in it. So yeah, in this package, this make we'll probably yeah use some of this stuff in this makefile because there's some very good stuff in here. So this is very platform specific stuff. So we kind of, depending on which platform we're going to include all the sort of the right libraries that we need for that platform. So you can see here we've got, if we're on Windows, we need to include all these libraries, and we'll use this compiler. If we're on Linux, we're going to include these flags and these libraries. And if we're on Mac, we need to include these things. So this is sort of our missing piece here because I'm on Mac. But if you're on Linux, you know, go and put these bits in, try it out, let me know if it works. Or you know, you can create a web version, or you can also create a Windows version. So what we probably end up doing is probably just using most of this code and just include that in our make file to make it very specific. But like I just want to keep it very simple at this stage and just include the absolute bare minimum stuff that I need for it to compile. But like if you're trying to create this and distribute it across multiple platforms, obviously, yeah, you'd want to include um, probably a fair bit of this make file, probably from like all of this stuff right through to the platform bit, and then potentially this stuff at the top here because there's some really good stuff at the top. But for now, just to keep it simple, I'm just going to take this Mac stuff. I think it's very good just to have it keep stuff simple at the start, so you sort of can control and you understand what's going on. So you can see here what we're doing here. We're including some libraries, so we're including the Cocoa library, Quartz core library, the Metal and the Metal Kit frameworks, and we're telling our compiler that we're actually using Objective C. From experience, I don't think I need that extra bit there, so I'm just going to remove that. Okay, and so you can, when we're adding this to our compile flag, you can see that this is actually an append. So we're appending the compile flags here. So we start off with an empty compile flags, we append this, and then we can append some more here. So let's just try that for a start. Yeah, we're still getting some errors. So what we need to do is include the libraries as well into our compile target. Okay, so let's just scroll up, have a look what our errors are now. Yeah, so we need to tell Sokol what graphics library we're using. So it says, unknown, must be Metal or GL Core. So we're either going to use OpenGL or Metal. So if we go back to our make file here, you can see that if it was Mac, I think it's down here. If the backend is Mac, it says the backend will be Metal, and then down here we've got to include this defs Sokol Metal. So let's just include that bit as well. And once again, if you're not on a Mac and you want to use OpenGL, or even if you're on a Mac and you just want to use OpenGL, you can use OpenGL Core, or if you want to use the web or Windows versions, yeah, just change this accordingly. So we're going to just take that little bit of code there as well. So we'll just put our definitions there. Now what I'm going to do is actually, just so this works with my compile flags, I want to just append the defs to the C flags. Okay, so then this metal will get added to the definitions, and then definitions will get appended to the C flag. So hopefully that will just work. So let's make that, and that looks a lot better. But we've got another little issue there. So let's just regenerate our compile flags first and just see whether that actually, yeah, it did. So you can see they're now compile flags and got the depths. We're saying we're compiled with the Objective-C compiler because we're using the Apple windowing system, and we're using Sokol Metal. So we're defining Sokol Metal in our library. Okay, so that's looking quite good. Yeah, we've got rid of most errors. We've now just got this conflicting main, so which is the same error we're getting here, conflicting main. So let's go back here and let's continue reading through our Sokol app. And yeah, so we've read through this. It says we're going to define one of these, so we've defined Sokol Metal. But once again, if you're doing this on a different platform, define your appropriate platform. Just going to zoom out on this a little bit. So yeah, I don't think any of these are necessary. Debug, so if we want debug, we don't want any of that at this stage. Some platform specific stuff here. Okay, so here we go. So link with the following system library. So we're on Mac, so we need to link with, for Metal, Coca, Quartz, Metal, and Metal Kit. So we've linked with those libraries. So that's all looking good. So if you're not sure how to see what we're actually linking with, we see make dry run. Yeah, you can see our exact command that we're running. So Clang, and we're linking with these frameworks. Okay, so that's quite good. Okay, so yeah, there's some good stuff here. Right, Sokol main. So this is what we need to do here. So with Sokol app, we actually add this Sokol main is what we're missing. Right. So there's a bit of an example there of how to add that. So we can just actually just copy that bit of code there. And we can just put that into our program here. So I'm just going to, oh no, not there. So yeah, with Sokol app, we actually don't define our own main. Sokol actually defines it in the app header. So all we need to define is our Sokol main. So we can actually remove this main function now, but I'm still on our print line there just to make sure that that works. So we actually don't need this main function anymore, but we have this Sokol main function. Okay, and print, and then we return this Sokol app description. So what that is, let's just remove some of these errors, right? So this defines the app description. So we've got a window, so 640 by 480. I think that's height, that seems quite reasonable. And then we need to define these functions, right? So my init function. So we need to define our own callback basically for an init function. So let's just define a void function for that. And we can just come in here and change that to our init. Okay. And we need a frame function. So let's call this frame. We need a cleanup function. And we also need an event function. Event. Okay, so I'm just going to define all these functions up the top here. So the void cleanup. And we need a event. Pretty sure the event function takes an argument, but I'm just going to make it void for now, and I'm sure the compiler will tell me what I've done wrong. And the last one is our frame function. So this will get called every frame. And this is where we can start putting some drawing actions. Okay, so we've defined our callbacks. Yeah, now if I go into the cleanup, oh, here we go. Here's our definition of our app description. So you can actually see all the different parameters we can have in here. There's a few different options here to make the app full screen, clipboard, lots of different options we can set, but we're not really interested in them at the moment, but we are interested in these callbacks. So yeah, the event callback has to take this constant event object, or this constant event struct, sorry, or pointer it is. So yeah, let's go and add that to our event function so the signatures match. Okay, so we've got an event, a frame, and init, and a cleanup. So yeah, that all looks pretty good. Let's just run that and see how we go. Okay, that worked. We're compiling now. We hit make run, and look at that. We have a window. Wow. So there's our little window, and yeah, awesome. All right, so yeah, let's just see what else we've got in this Sokol app. So we were just looking through here. We've created our main function. We can include a logger, so we can use the Sokol log package to do some logging, but we're not going to worry about that for now. Yeah, these are our callbacks. So we've added all our callbacks. We've got an event callback. And yeah, we can, with different functions to get window height and width. Yeah, this all looks pretty good. So yeah, all right. Well, yeah, that's about it for the setup of the app. Next time, I think what we're going to try and do is just, I want to have a real quick shortcut keyboard where I just hit escape and that'll just close that window, and that just allows me to sort of run make run, and then I can quickly get out of it. So yeah, in the next video, we'll have a go at that. Okay, I'll see you then. Hey everyone, Tim here again. So we're continuing on where we left off in the last video, and what we've got up and running is the Sokol app. So we've installed Sokol app, and we are now ready to do some programming with it. So we have a look at our little program. We've set up some basic functions with a frame, an event, and a cleanup. And when I make run, we've got a little window. So the next step, I just want to create a little shortcut that I can just hit the escape key and close that window straight away. So we're going to just muck around with this event here. So if we go into the event, we can see we've got all this data here. So we've got the key code, which is very important, tells us whether the key is up or down. If we're doing some stuff with the mouse, we can check the mouse status, but at the moment I just wanted to create a keyboard shortcut. And we've also got the event type. So let's go into the event type and see what type of events we've got. Okay, so here we go. We've got key down, key up. Um, see, I think we might just do key down. And then we've got the key code. So let's just come in here and let's just go if the event dot was it the type? Forgot what the field was now. Yeah, the type. Yeah, if the event type is the key down event, we could put this in a switch, but for now we'll just put in a little if statement. So if we get a key down event, now we also just want to check that the character code is some particular code. So for now, I'll just put 0, but let's go and do a bit of research into what our character codes can be. Sorry, it's the key code. So we have a look at key codes. Here's our key code. So these are all the different keys we've got. We've got the F keys, function keys, up and down. Yeah, and all the different character keys. So if someone hit the A key, you would use that key there. But what we're after is the escape key. So this should be in here somewhere. Escape? No. Maybe I'm missing it. There it is, escape. Okay, so we want this escape key. Okay, so if we hit a down key and escape key, what we want to do is we want to go SAP. And I think we just want quit. Let's just try that. Okay, so that looks good, but this doesn't look good. What's going on here? Ah, okay, so this is a pointer. So instead of doing that, I should be doing a dereferencing operator. Okay, that looks better. All right, I think that looks good. So let's make run that. And I'll hit escape and nothing happens. Okay. Why did nothing happen? Key down. Well, I'm not really sure why that's not working. I mean, I guess I could do key up. No, that doesn't work either. Okay. Okay, so I think event type, key code, key up, key down. Okay. Uh, can anyone see what I've done here? I'm sure you're screaming at me in the comments. Okay, let's just do a bit of old-fashioned debugging. So we'll just print out this stuff and we'll see what we're actually getting when I hit that key code. All right, so we should then make run, and if I hit escape, you can see I am getting some data out. Okay, cool. So what are we doing here? It's a bit hard to follow. I think I need to do that again. But 3 and 20, yeah, when I move the mouse, it gives me a heap of stuff out. So maybe I just need to move this into here. I don't get so much noise. Okay, so that's sort of working. So the down, this is 1, I guess. Yeah, okay, so down is 1, so this would be 0, this would be 1. Okay, so we're getting that correctly. And the key code is 0. Character code is 0. Why is the character code 0? When I hit the escape key, it should be that. Character code is 0. Why is the character code 0? Okay, because it should be key code, not character code. Okay. So this is the problem. Okay, so I'll put character code, so I'll be using this one, but it should be the virtual key code. Okay, so yeah, it should be key code. Right, key code. Okay, I'm pretty confident this is going to work. I will just keep that print line there. Make, run, escape, done. There we go. So see that? I hit make run, hit escape, and I close it out straight away. So that just allows me to sort of keep my hand on the keyboard and just quickly test it, escape it, and I'm back to the code again. So, okay, there we go. So I think we just run like that. Boom. Excellent. And there we go. So that's yeah, that's how we do events, and we can obviously check for any sort of keyboard events, any mouse events, and we can just look for certain events and then perform certain actions when we get those events. So yeah, that's it for the video. In the next video, we're going to get some graphics going, and we'll yeah, we'll start drawing some frames. So yeah, check out the next video. See you soon. Hey everyone, it's Tim here. We're back. We're doing a bit of Sokol programming, and we're going to yeah. So we've just set up a little application shell using Sokol app, and when we hit make run, we get a little application. We hit escape, and it quits the application. And you can see here, this is the main program. We're setting up a window, and we've got some callback functions, which don't do much in the callback function, except the event one where we check the escape key and we quit the app if we hit the escape key. So that's all we've got. So now we're going to jump across and we're going to actually do some graphics. So we've got this Sokol library, and what we want is this graphics one. Sokol GFX. And what we probably just want to do is just the hello world of like just draw this basic triangle. There's a sort of example here. So yeah, that's what we're going to try and get going. And here's the example code here. So we'll probably just, yeah, use some of this code here and yeah, we'll get it set up. But the first thing is we've got to get this Sokol GFX file. So we can just jump across into here and we'll hit raw. Okay. And yeah, there it is. So what I like to do, just to make the updating, so I'm actually installing these dependencies, single file dependencies in the steps folder for dependencies, but I just want to create a little make file to make that a little bit easy. So let's just call this Sokol. And what I want to do is get that. Okay, but where I want the output of that file to go is into the depths. And I'm just going to call it Sokol gfx.h. Okay, now we'll give that a run, make Sokol, and yeah, look at that, and goes and fetches it. Okay, that looks really nice, and there it is. Beautiful. Okay, so what we'll also do, we'll just copy that one, and we'll just do the app one as well, because why not? So we just update this one here to app. Okay, and then, you know, if we come along at a later date, we'd probably check this into Git. And if we want to update our dependencies, we can make Sokol, and it will just go and fetch the latest version of those files. And yeah, we could update it that way. So it's also nice. I sort of have this repo here called single file libs, where I've got a bit of a make file, and I've got all the different single file header files that I occasionally use. So, you know, I can just come and grab any one of these that I want to add as a dependency, and I just add them to my make file, and then bang, I've got that file in my project. So okay, so that's nice. So the next thing is let's actually look at this thing here and let's see what we need to do. Okay, so in here we've got to find Sokol implementation. So we've already done that, and we're going to find a backend which we're using Metal. So watch the app setup if you want to see how we set that up, but you need to define one of the backend that you're using. So if you use an OpenGL, you would use the GL core. I think that's GLES3, I think is the mobile version, but yeah, I'm not that sure on that one. D11, that's the DirectX version from Microsoft. Metal is Apple. WGPU is the web. Yeah, so just include the one that the backend render that you want. Okay, so we're doing this, and then oh, we need this glue. Yeah, rightio. So let's first up, let's just include the file and see what happens. Call GFX H. Okay, let's just make that. Okay, that actually just worked. That's pretty cool. Okay, now, so the glue library, let's go back to what it says. Okay, depending on your selected backend, Sokol GFX requires some information about its runtime environment, like a GPU device pointer, device swap chain pixel formats, and so on. If you're using Sokol app, which is what we are using for your windowing system glue, you can use a helper function provided in the Sokol glue. Okay, so we need Sokol glue. So I'm going to take a little guess here of where that's located and just put glue here and put glue there. And I mean, yeah, we can just run that command there. Okay. And have we got our glue file? So the glue is, yeah, just a helper function that sort of ties those two applications together so they don't have to depend on each other, I guess, which makes sense. Yeah, we just need to do this Sokol setup and set our environment. Okay, so let's do that. What do we got? Sokol. So yeah, with these defines, you can obviously define just the one for that particular one, or you just define the Sokol implementation for all of them, which is what we're doing here. So you can see here we've got this Sokol implementation. So let's just include our glue as well. Glue. Okay, so it doesn't like that because I can't spell includes properly. Make. Okay, excellent, that's working. So let's get back to here. Let's yes, set up GFX setup. Right. So we've got a GFX, we've got our app, we've got our glue. Now we need to set up the Sokol. Okay. We won't worry about the logging, but the logging you just follow a similar process and you can set up a logger. But first thing is let's just set up our Sokol. So Sokol setup, description, and then environment. All right, let's do that. So in our init function, let's go Sokol setup. Okay. And so it takes a Sokol description, a pointer to a Sokol description, which will look like this. Okay, there we go. So that's looks pretty good. So let's make that all still works. Okay. So in our Sokol description, these are all the things we can set up. So yeah, so the environment, we've got a logger, an allocator. We don't really need a logger or allocator at this stage. We can set different pool sizes. We're not really interested in any of that, but this environment. Okay, so this sets up the different like back end sort of environment. So our glue is sort of going to do all that magic, setting up all that for us. So all we have to do is come in here and say dot environment, and that equals SG glue, I think, was it? Can't even remember. Where was it? S glue. Okay, S glue. S glue environment. Is that a function? No. I'm just going to copy that because I'm not sure what I've done wrong. Once again, I cannot spell environment correctly. Okay. And that should be. Okay, there we go. Right, so you can see what it does here. So it basically does a heap of stuff to get the color format, the depth format, color, devices. So it set up all the devices for the particular platform that you use. So yeah, that's pretty cool that that does all that for us. So let's make that. That looks good. Okay. Righto. So let's just go back there. We've set up that. We can set up a logger function. We're not going to worry about that. Okay. Now we need to create some resources. So we can create a buffer, an image, a sampler, a shader, a pipeline, or attachments. Begin a render pass and swap the chains. Apply the pipeline, and then we do a draw call. Okay. So let's just look at the example and let's just look at what they've done in the example. So this, let's look at their init function. Okay, so we've got a sort of application state here. So we've got a pipeline, a bindings, and a pass actions, and then we've got yeah, we've got a clear color. So let's do here. Okay, and we've got an SG shutdown. Okay, so first thing I think we just need to shut down. Let's make sure that we're clearing this thing. Okay. Let's just make sure that works. Make run. Okay, beautiful. I don't think I need, oops. Don't think I need this hello world anymore. Okay. Right, so let's what we'll do first, let's just see if we can do a draw frame. Let's create a let's create our application state here as I have an example. Okay, and what we're going to do, what we might just do is okay, so let's set up a pipeline, and we'll just call it pipeline. Let's set up the bindings, and let's set up our G pass action. Okay. All right, so we've set up that. Now let's just try and set the pass action to SG pass action. Now, if we look at this pass action object, you can see that it has these colors, okay? And in the colors, there's a load action, which is clear. We can set this to clear, and we can set the color value, clear value, okay? So what we can say is we actually want dot color. And because this is an array, if we look in here again, oh, you can see here this is an array. So we've got an array of colors. We set the first color, and in the colors we can set a dot load action. And the dot load action is SG load action clear, and then we can set a clear value. Okay? And the clear value can be whatever color we want. And this is just an RGB color, so we can just set it to, that's between 0 and 1. So we can set it to, let's just do a nice light color for a start. We'll make these floats. So we'll just go 0.1, 0.1 F. So 1 is black, I believe, and 0 is white. Is that the other way around? Let's just see. Okay, what have we done here? This bracket here shouldn't be there. Okay. Right, now we've got that pass action. What we should be able to do with our frame is actually begin our frame, begin the pass. Okay, now the pass takes a SG pass. Okay. And so this is a struct like that. We look at the SB pass and it has a pass action, and we can also have put in a swap chain. So let's put our pass action in here, which is all we want our pass action equals the state dot pass action. This is actually just called action. Yeah, action. Okay. And we can put the swap chance, which we just need to use the glue. Okay. Right. So then we can just say SG npass and SG commit. Let's make that and see if we works. Okay, look at that. Now, if we change our color just to make sure this is working, so 0 is black, I believe. I think I said 0 was white. We've got black, and we change this to 0.9. This should be a very light white color, very light white. And it is like that, beautiful. Okay, so that's our, we might just go for a sort of a mid-grey for that. Okay, actually I think we'll go, I think we just might go 0.2. Okay, yep, that's beautiful. Okay, so now we're clearing the screen and we're rendering. So yeah, in the next one we'll attempt to create a little triangle. So I'll see you in the next video. Hey everyone, it's Tim here, and we are back. We just set up our Sokol 3D pipeline, so or our graphics pipeline. So in our last video, we've set up this state. We're copying the example in the Sokol app, and we've got a pipeline, some bindings, and a pass action, the render pass actions, and we've set that in a global state variable. And every frame we are beginning our render pass, we are setting the pass action to whatever we set in the init stage, and we're doing using our glue to swap chain. So swap chain, I believe, is I could be wrong, but I believe it's swapping sort of the buffers from our back buffer to our front buffers. So one of the actions when we set up a pipeline. Now, if we look at it on init, we set up our environment for a start. We're using so-called glue to glue the GFX library to the app library, and then we're setting our actions. And our action is just a clear action, and we're setting it to this clear color. So we're basically just setting absolute basic clear color. And yeah, when we go make run, we've got this little app, and that's our background color. It actually matches the Mac background, but that's just a little bit of coincidence. Okay, so what we're going to do now is set up, we're going to do some shaders. So we're going to set up a shader. Now, the good thing, what Sokol allows you to do is write shaders in a general sort of shader language format, and it will compile them to multiple different sources. So if like we are just at the moment, if you watch the setup videos, we're using Metal, we're on Mac, but this video could apply. You could be using OpenGL or DirectX or the WebGL, whatever you prefer. And you could set this up as cross-platform, but we're using Metal. So we could just go and write our shader in Metal and be done with it, but then obviously we lose all that cross-platform ability of it, and that's sort of half the point of using Sokol. So what we want to do is have a utility to compile our shaders to a cross-platform sort of in a cross-platform style. And Sokol, it's a little bit hard to find, but on the Sokol GitHub, if you scroll down to the little bit that talks about Sokol GFX, there's a little bit here that talks about shader dialect cross translation. Okay. And yeah, this is this is now the official shader cross compiler solution. Okay, so we can click here for details. Okay, and this is it. It's called Sokol SHDC, which I'm assuming stands for Shader Compiler, would be my guess. Shader Code Generator for Sokol GFX. Okay. So you need to install this binary called SHDC. Okay, and now there is lots of ways to do that. You can compile it from source, and there is also some in the Sokol tools bin. There's another GitHub repo that has a pre-compiled binary. So if you prefer to build it from source, go ahead, follow the instructions. Else, come into this shader tools bin repo. I'll put all these links in the description. But if you go into the bin folder, there's your platform binaries. So I'm on OS X. I'm on an ARM, the latest. Yeah, and there it is, the Sokol SDCH binary. So download that, make sure it's in your path, in your bin folder, wherever you sort of put your bin folders. So for me, I have in my home directory, I have a bin folder, so I've just moved it into there. So pretty sure I've got a sys, yeah, Sokol. Okay, so you can see here, this is where I've installed my binary, and it sits there in my folder. So now I can just call this Sokol SHDC, and I've got my compiler there ready to go. Okay, so now we're going to let's create a shader, and yeah, let's do it. So in our source file, let's add a let's just call it yeah, let's just call it shader dot g gl glsl, which is our shader language. Okay, so now there's some instructions on here to how to write our shaders. So we're going to just do the absolute sort of bare minimum example, really. There's a real simple one here. Yeah, this is it. So yeah, you can see standalone usage. This is how we're using the tool. So yeah, I think if you're using it, so Sokol uses this FIPS build system, but we're using Makefile, so we're sort of ignoring all that. But if you were sort of following along with the FIPS build system, you could sort of include that into it. But we are just going to use a standalone usage. Okay. So yeah, this is our shader. So what we can do, we can have a vertex shader and a fragment shader. So we define the two shaders in the one source file, the GLSL, and it's using the GLSL source files, and then that will compile it to the different shader sources. So we're going to create a vertex shader. So let's yeah, I'm just going to put this in another window so I can just sort of copy it along, and as I type it out, and then we'll yeah, so in here we'll create a vertex shader, and I'll talk through it, and we're going to call our vertex shader VS. So this is, I believe this at symbol is custom to the Sokol shader tool, and then the rest of it, now the dialect after this is actually the GSL, yeah, .glsl, which is the OpenGL shader language. Okay, I'm not a shader language expert by any means, so if someone, but I believe it's like, yeah, there's a particular version that's using. So if you read through it, it probably will explain it in a bit more detail. So yeah, so we can see here, this is our vertex shader. So we've got the start of the vertex shader, we're called VS. We've just happened to call it VS. I believe you can name this whatever you want. And then this is the end. So everything in here is the vertex shader, and we're just using, yeah, the OpenGL GLS dialect. And so we've got an in variable, which is this position. So we're taking in a vector 4 as the position, and all we're doing is setting the GL position to that position. Okay, so it's really just a pass through. We're not really actually doing anything with it. And then we also have a fragment shader. Okay, so we have a fragment shader we're calling FS, and we'll end our fragment shader here. Okay, and in the fragment shader, we're going to have an out variable. So this is what we're going to be outputting, which is the frag color. Okay, and we create a main function. It's very similar to C, sort of like, and then we set our frag color. And in here, like what you would eventually do is pass through this color from the vertexes, but we're just going to absolutely set this color to, well, yeah, in this example I'm just copying is actually just set it to red. So you can see that one is red, one R, G, and then B, R green, red, green, blue. Okay. So, and then the last bit is the alpha color. So we're going to be full transparent and we put a semicolon at the end. Okay. Now we've got a fragment shader, a vertex shader. Now we also just need to make a program. Okay. So we just call that program, we can call it whatever we want, but I'm just following the example. SHD is our name of the program. And in the program, we're going to include the vertex shader and we're also going to include the fragment shader. Okay. And that is our shader. Okay, now we just need to compile it. So let's just have a go at compiling that without following the examples and see how we go. So we'll just run that. We can see we get an input path. Okay, so let's put our input to our input file, which was source shader, and let's also set our output. And let's put it to source shader GLSL, and maybe I believe it produced a dot header. So let's just run that and see what it does. Okay, no shader language, perfect. Okay, so we now to send this shader language. Okay, I hope you could see all that on the screen then. So let's go back to our thing here, shader language. So we can set, this is where we're going to output the different shader language. So we can set, you know, the versions of OpenGL shader language that you want to use, whether you're using Metal, etc., etc. So there is lots of documentation in here about the different, here it is here, all the different shader languages that you can set. So you can see OpenGL 4.1, 4.3, the web versions, DirectX versions, Metal, Metal iOS, and WebGL. Okay, so just you can actually set multiple languages at once. So I'm just going to use these ones here in this example, but like depending on the platform you're building for, just set this accordingly. I don't think you can set all of them at once, but you can set sort of a multiple one. So let's just set this. I think we just put a space, did we? Yeah, a little space there. So let's set that. And we've got an error. Okay. Undeclared identifier position. What have we done here? I think I spelled position wrong, have I? Missing an I in position. Okay, perfect. Let's update that. Let's rerun it. And frag color is an undeclared identifier. I'll put flag color. Okay. So we'll fix that as well. And compiled. Okay, let's have a look at our output now. So what that's done is generate this shader GSL file, as I've specified in the output, .h. Okay. So you can read through this, but it basically generates a source file, and this is the actual binary. So normally when you generate a shader, you need to compile it and then sort of include that, but this has actually included the compiled version as a binary number that's then just imported into as a header file. So we can just import this source file here, and we've got all our shader code there. And in comments, it sort of has the different dialects as it was compiled. So this is OpenGL version 4.3. So you can see the, and then this one's, oh, this is, yeah, sorry. So we've got the vertex shader, and then we've got the fragment shader in OpenGL 430. And then this one is the, yeah, different. I'm not sure what this one is. Someone in the comments might be able to explain what all these different ones are. Oh yeah, this is the HLSL5 version, which I think was the DirectX. Did we ask for that? Oh yes, we did. We asked for that here. Okay. And we also asked for a metal version, so we should have a metal one in here as well. So oh yeah, here we go. So here's our metal. It's our metal shader. So we could just include our metal shader if we only wanted to write that, and we could just write this out by hand. But this compiler is basically written it all out by hand and then compiled it into this binary source here. Well, actually, I don't believe it's compiled. I believe this is the raw text of that comment, so it's not compiled yet. But once we pass into the shader, it will into the program, it will compile it. So Yeah, right. So yeah, there we go. So we've generated our shader. So in the next video, we'll have a go at including the shader into the pipeline. Okay, thank you. Hey everyone, it's Tim here again, and we are setting up a Sokol environment, and we've just set up our shader. So we've just compiled our shader right here. Now you'll notice that I've actually renamed the shader wrong there, so this actually should be glsl.h. Okay, so yeah, we've set up our shader. So this is our compiled shader we've got here, and this is a function here that we can call to get the description of the shader, and yeah. We're going to include that into our main file. So the last command that we ran was this one. So just to make this a little bit easier, we're going to include this into our make file. Okay. So down here we're going to create a shader. Okay. And um, that's not what we want. That's still not what we want. Sorry. All right. Sorry. I'm just trying to copy this here and we'll just paste that there. There we go. Okay. So the dependency for this is what we actually want to generate is actually what we want the output file to be shader glsl.h. So this should be glsl, and we want this to be the dependency. Okay. And this is source. There we go. And what we can do is make a phony target here. So we might just create a dot phony. Phony target is when you're actually we're not actually generating a file. Okay, so we just say the phony target. I think this will work. Source shader GSL H. Now we should be able to just go make shader. Okay, that didn't work. Oh, nothing to be done. Yeah, that's correct. Make dash B shader. There we go. Yeah. So now if I edit this file, save it, and just hit make shader, it will regenerate that file. Okay, beautiful. Okay, now in our main file, we can include that file. Okay, so we can just include that header file, which is shader glsl.h. Okay, and when we compile our main file, any changes to that header to that shader file, we want to recompile our program. Okay, make. Okay, beautiful. So that's now including the source for that our shader into our main program, right? So now we've got to set up a bit of stuff here. So what we need to do first, so what we're going to do is follow this example, right? So you can see here in the init, we've got our setup function. We're going to have this vertex, right? So we might just copy this vertex because I think that's going to be very important. So this is, so what we're trying to do, we're trying to generate this triangle, right? So we've got sort of, basically there's three vertexes, one here, one there, and each one is a color. So this is red, this is blue, this is green, and then the shader will actually, as it renders, it will interpolate between all those different colors. So you can see here the positions. So we sort of have this set up like, I don't know if I can kind of draw it. This could be risky trying to draw this as part of this video, but you sort of have this grid set up where this middle point is 0, 0. And as we go across this direction, we're 1. And this is on the x-axis, and this is -1. And then up the top here, we have 1 up the top, and down the bottom there, we also have -1. Okay, so we've sort of got this little grid, if you could imagine this as a grid. Okay, and this is sort of the y-axis going this way, and this is the x-axis going, horizontally. So anything in this area be +1, over here will be negative on the x and positive on the y. This is negative on the x and the y, and this is positive on the x and negative on the y. Okay, so that is our little grid setup that we have when we're drawing. Okay, and you can see here, so we've got these positions. So this is 0, 0, so this is right in the middle. Sorry, this is a 2D. Yes, right. Sorry, this is a 2D plane. So the first position is 0, 0, and the next one is FF. So 0, 0, meaning 0 on the x-axis, and it's about halfway on the y-axis. So this is this first point here. So this is the first 2 dimensions. The third dimension is depth. And because we're on a 2-dimensional plane in this example, we can draw in 3D if we want to, but we're just drawing a 2D shape. So they're all got the same. This is the z-axis, right? How much depth it's got. And for the purpose of the example, it doesn't really matter. This could be all 0, but the example's got it as half. I'm not sure why it's got it as half, but yeah. And then the color. So the color here is red. So red, green, and blue. And then this is the alpha color. So you can see it's all fully transparent. And this is this second point is blue, and then this point is green. Okay, so there are our vertexes. Okay, so there are our points that we're going to deal with. All right, so first thing what we need to do with these vertex, we need to put it into a buffer. Okay, so I'm just going to sort of follow along here, but we set up a bind, and we've got a vertex buffer. Okay, and we're just going to set it in the very first element, and there's a function in Sokol called make buffer. So we're going to make a buffer, and we can just pass it the buffer description as the argument. Okay, and the buffer description just looks like that. So we okay, and what we do is now set the data of the buffer. We use this SG range, and we just pass it the vertex. Okay, and the label can be anything, but we'll just call it, as per the example, triangle vertices. They should be commas, not semicolons. Okay, there we go. So we've set up our buffer. Okay, this is our bind buffer. Now we've set up our buffer, we need to now set up our shader. So we can create an SG shader, and we'll call it our shader, and all the so-called functions that start with SG, and then basically when you want to make a resource, there's a make, and so you can make buffer, shader, attachment. So obviously here we want to make a shader, and you can see that it takes a shader description. So we will pass in a shader description. Okay, and once again, we will set that up. Okay, so for the shader description, oh, actually, yeah. So the shader description, what we can actually do is, so instead of passing, so we could actually, sort of fill this structure out ourselves. So there's all this sort of data here, the vertex functions, the fragment functions, compute functions, right? So all that stuff, but that's already done for us as part of our generated shader code, right? So if we go across to our generated shader code, you can see this function called shader description, and you pass it in a backend, will actually, depending on the backend, will sort of set all those values for us automatically. So we've got, we've got a GL core backend, we've got a D11 backend, and we've got a metal backend, right? So we've got the three backends, and all that data is already set for us. So we don't have to set all that up manually. We can just pass that in by just calling that function because we're including that file. So let's include that function. I forgot what it's called now. Yeah, so this is shader description, right? So we can include the shader description as a function. Now the shader description takes a backend. Now we can get the backend by using a function in the SG library called query backend, and that will actually determine the backend for us. So we could use the compile flags, which sort of set it when we set it, but we can just query the backend. We can get the backend, and that will give us the appropriate shader. Okay, now we've got the shader. We actually need to set up our pipeline. So we will also do that. So we'll set our pipeline. Now we have a state variable that we were going to set the pipeline. So we're going to go sg make, and we'll make a pipeline. Okay, and once again, this takes a pipeline description. So this is a common pattern in Sokol where we just make a resource and we pass it a description. So we pass it a pipeline description. Now you can obviously use this as a variable, right? You can create that as a variable, but we're using yeah, a C99, I believe, feature, which is called, I forgot what they're called actually. I'll think of it later. Um, struct literals, I believe is what they're called. So we're using these struct literals. But I haven't quite done this right. What have I missed? Ah, that bracket there shouldn't be there. Oh no, sorry. So this should be a bracket around here like this. That's better. So struct literal. So it's instead of sort of declaring a struct here, so we could sort of declare a struct like SG pipeline description and just call description, sort of declare the variable there and then pass a reference to that description in here. Right, so we could sort of do something like this, right? So we can sort of declare the description and then pass it in. We're doing a struct literal where we basically just embed that struct directly in the arguments of the function. Okay, so we don't even need that. So then the arguments of this description, we can have a look at this again. And you can see here, we get in the pipeline, we can set shaders, we can set the layout, and we can set some other stuff. But yeah, we want to set the shader. So we have a shader and we're just going to set it to this shader we created above. SDH, okay. SHD, sorry, is what we called it. And yeah, now the next bit is a little bit tricky. So yeah, if you're wondering how I'm doing this, I'm just kind of following along on this example right here. So we've set up our pipeline and we've set up our shader, and now we just need to set this layout. Okay, so the layout is basically the way this data here is structured. This is our vertex buffer, right? We need to tell the 3D renderer how our data is laid out. Okay, so I know this is laid out like this because I've got all these comments are here, but you know the program doesn't know that, like how many floats are or what type of data this is. Are these floats like? So we just need to describe this layout, right? So the way we do that is just say layout, and we're going to describe our layout. Okay. And in our layout, you can have a look at what our vertex layout state is. So we've got a layout state buffer and a layout state attributes, okay? So the layout, we have attributes, okay? And so we just set our attributes of our layout. Uh, yeah, attributes equal this, sorry. Okay, so this attributes is an array. So we're going to say what are our attributes. So we're going to say the first attribute. So this is an array. So we're basically saying the first one, the format is, and this is sort of saying what is the format of this position vector, okay? But when we compiled our program, if we go to our shader program that we compiled here, up the top here, I believe we defined these attributes. Where is it? Yeah, here. So this define attribute shader pos. So this variable, this position variable, is defined as position 0. Okay, so the shader program actually defines where that position is, because that's going to be sort of how the shader and our program communicate, right? So they're saying this is in position 0, right? And this is what this layout 0, I believe this is what this location 0 is there in the shader program that's generated. So to make sure that we get the right position, because if you've got lots of variables coming in, you're just going to make sure that they all sort of match up. So if we go back to our main program, so instead of saying 0 here, we can actually just say the attribute shader position. Okay, so that is that there. And the format of that position is just SG vertex format. Okay, and we've got a float and 3. So this is saying it's 3 floats. Okay, so as you can see here, our position is 3 floats. Now, there is a bit of a mismatch with our shader and our colors that I've just realized. So our shader doesn't actually take a color. Our vertex shader doesn't take a color, it just takes a position. So we might adjust that, but for now, I think what we're going to do is actually just adjust this shader. No, sorry, adjust our vertex to not include these colors. Okay, so I'm just going to remove these colors, and then in another video, we'll add the colors back. Okay, so at the moment, I'm just passing in positions. So that's it. So you can see here, I'm just passing in positions, and the format is float 3, meaning 3 floats, right? So each position is 3 floats. We pass that to our shader, and we can also set a label. So we just set a label. I actually don't even know what the label does, but let's just be good citizens and set our label. Okay, right now that's all looking good. Okay, so we've set up everything there. We've set up our pipeline. Now the last thing is when we draw our frame, we've got to actually apply this pipeline. So we've set up a pipeline. This is in a global variable called here pipeline, where our vertexes are in our bindings. Okay, and we've got our action. So now in our frame, so every frame we're going to begin our pass actions, which clears the color. Now we need to apply our pipeline. So we can apply pipeline, right? And we're just going to use our global state and use our pipeline there. Okay. And we also need to apply our bindings. And we'll also use our state. And the difference here, this one takes a pointer. So when we go to bindings, you can see there that takes a pointer to bindings. The pipeline is not a pointer, it's just actually an ID, right? So when we make it, it just returns an integer ID, whereas the bindings is actually a pointer. So we're just going to make sure that we do that. We end the pass, and then the last step is to draw the thing. So let's call SG draw. So this should draw everything in our pipeline, 0, 3, and 1. Now I believe those arguments are the base element, which is I think where we're starting. I might be wrong on this, but this is starting at 0, meaning draw the first vertex. Number of elements, we've got 3 vertexes, and number of instances 1. I don't even know. I'm actually not sure what that is, but we'll figure it out as we go. So I think that's it. So let's run it and see what happens. Let's make run. And look at that, we have a red triangle. So how about that? That is awesome. So we've drawn our triangle. You can see there, this is our position. Now, if you wonder why it's red and not the colorful one that we're trying to get, that is because we are not passing through any colors. We're just passing through positions. And in our vertex shader, we are setting the color to red. But if I change this to blue and run it, we don't get a blue, we get a green one because it goes red, green. So this is green, not blue. And if I go like this one should give me a blue one. There we go, there's blue. So, we can sort of get any color we want now. So we can get a black one, and if we want white, we'll go one for white, one all the way through. Look at that. And if we do a red, but we give a little bit of transparency. So this is the alpha color. We should have a little bit of a light red color. There we go. So there's no transparency. I don't know why that's not working, but potentially it's something we've got to set to get transparency there. But yeah, anyway, that's very interesting actually. Anyway, yeah, in the next video we'll have a muck around with some. We'll get these colors and we'll get the colors working in the shader. All right, I'll see you next time. All right, hello, and we are back. We are, yes, Tim here, and we are setting up a Sokol demo, and we've so far we've created a shader, and we're putting it into the pipeline, and we're drawing some triangles. So at the moment we've got this little triangle. We've got this little red triangle that we're drawing, but the color red is hard coded in the shader. So what we want to do, so let's just have a quick look at that again. With this, we've got a vertex shader here, and we're just passing that, we're setting the position according to the position that's passed in the in variable, and then we're setting the out color of the fragment shader to this hard coded red color here. Okay, and that's why we get this red triangle. But we want to change that around a bit, and instead we want to be able to pass the colors in. So we get this nice, in the demo app on the Sokol examples, we've got this sort of nice rainbowy color. Okay, so we've got red up the top, we've got green down here, and we've got blue in the left corner, and it sort of interpolates between all the different colors. So yeah, the main difference is here is that with this shader, we can actually take in the color from the shader, and we just pass it through, straight through to the fragment shader, and then we set that color in the fragment shader. So we're gonna have a go at that, and we're gonna see if we can get some nice rainbow colors. So let's take in the vertex color. Now we've got to just make sure we give it a different name. So if we have a look over here, we've got yeah, this is color 0 because our out variable is color. Okay, so our out vertex is color, just color, and we set our color to be just the in color of 0. Okay. Now in our fragment shader, we take an in variable called color, and we should just, instead of setting it to this hard-coded red, we should just set it to color. Okay, so I'll just check. I think that looks pretty right. Okay, well, let's just make our shader. So I'll just clear this. Let's make shader, and that does generate our shader. Okay, it's beautiful. Now, what we need to do is we're going to actually set all these colors in our vertex buffer. So we've got our position, the first 3, and then the next 4 floats are actually the color. So what we need to do there is actually set another attribute in our pipe when we're making our pipeline description. Okay, now if you watched the previous video, you would know that this is just an array of attributes, and we're saying each attribute. So this is essentially like saying, in the array 0, set it to the format to whatever, and then this is like array numbers to 1, right? And we also set the format to whatever, right? But because if we move the position of the variables around, they might change order or something. So we can actually just specify these as defined. So, and these are actually generated as part of the shader code. So if we go into it, you can see here we've got shader position 0, and then we've got shader color 1, which was and this is defined as number 1. So what we can do is just change this one to color 0. Now, this is where we need to change this. So the format, this format is this color up here above here. So we've got they're floats, but there's 4 floats. Okay, so we just need to tell our vertex pipeline that these are this color is 4 floats. Okay, now if all goes well, we should have some color. So let's run this, and look at that. We've got a beautiful shaded triangle as per the example, and we can resize this, and beautiful colored triangle. So there it is. Yeah, that's the intro to Sokol. That's how we sort of set it up. But yeah, really awesome library. If you go on here, there is a live sample of all the different, we've done this triangle one, but there's endless amounts of graphic stuff that you can do with this library. And yeah, I'm going to keep playing around with this library. And yeah, hopefully if you enjoy this video, please give it a like and share it, and we'll yeah, I'll do some more of them. All right, see you next time. Hey folks, it's Tim here. Yeah, what we're going to do now, we've just been developing this little Sokol app, and we've been able to draw a little triangle on the screen. So when we run this app, we get this little triangle with lots of colors. So yeah, one little thing I'm just going to tweak with it is just with the makefile and the build system. So the problem we've got, it's not the biggest problem in the world, but it just everything's about speed sometimes when you're developing and getting quick feedback. So when we run this, it's that obviously runs quite quick. We hit run and it runs, but you could, because we've got this build system with use and make, there's not actually rebuilding this every time. So but as soon as we make an adjustment to the source file, so even if we don't make adjustment, we just write that change and we hit make run, we've got that little second delay in terms of how long it takes to build that app. Now at the moment we've only got 3 dependencies, but as we add these dependencies in, that build time takes a little bit longer. So, and I'm on a M1 Mac, and it builds pretty quick. So potentially we just don't want that build script. Now my C file is very small, so like that the build step in that is very quick, but this GFX library is 21,000 lines long, and this Sokol app's 12,000 lines. So every time because of the way we've got this set up, we've sort of just including these directly in this main file. We're kind of rebuilding that in the single compilation unit. So we're rebuilding the entire source code every time we hit make run. And well, not every time we hit make run, every time we make a change to our source, we rebuild that entire app. So what we're going to just quickly do is make a little deps.c file, right? And this will be sort of our dependencies that we can include all our C files in here, right? And so what I'm going to do is grab this little bit of line of code here, put that in there like that. Okay. Now, but what we really want is the way these single header file works is that we can kind of include these multiple times, but we only want the C file or the implementation file done once. So this is the implementation. So this C file here, this deps.c file, will be the compilation unit, which will include all the source code. And then every other time we include these will just the header definitions. Okay, so in our main C file, we want the header definitions. I just want to split that out there. So this is our shader file. These are our dependencies. So maybe we just put a dependencies here. So yeah, these are our dependencies, and this is our shader. Okay, so and then these ones are sort of the standard lib. Well, let's just say libc. We don't really need that line. Okay, so right, so that's how that's going to work, right? So we can, but now we need to actually set up our make file to sort of do that, right? Because if we just go and make this now, yeah, we get all these linking errors, okay, because it's not really building properly. So, all right, how are we going to do this? So what we want to do, we actually want to build, first thing we probably need to do is build a deps.o file, okay? And it will depend on deps.c. We probably should depend on all these Sokol libraries. So if we update them, we can kind of, um, include that in it. So maybe we will do that. So let's just say our dependencies are Sokol app.h, Sokol gfx.h, and Sokol glue.h. Okay, and then I think we can, oops, we can just put our deps here. These are our dependencies. Right, now to build our deps.o, we're going to use clean. Once again, if you're using GCC, just change this to GCC. If I was setting up this make file in a sort of general project, probably should create a CC file up here and sort of set it like that. But yeah, for now we're just trying to keep things as simple as possible. So we want to do a -c, which will generate an object file, and we just want to use deps.c. Okay, and that's it. So let's just see if that works. But because this is actually in this folder, we just need to include this in the folder like that. So can we make deps.c? Oops, deps.o is what we will make. Okay, so these are actually in the deps folder as well. Not sure why that's not working. Let's just try that without that for now. Let's see what happens. Okay, no such input file. Okay, so this should be deps.deps. A lot of deps going on here. Okay, right, there we go. Okay, so that looks good. So we're actually compiling that now, but we get some Objective-C errors, which means that we're not including our C flags. Okay, so let's include our C flags, which will include our Objective-C compiler. Okay, there we go. So let's just have a look here. Have we got a, we've got a deps.o. Okay, that created the deps.o there. It's not where I was expecting it to create it, but I mean, yeah, that kind of works. I don't know. We probably should create a build folder and sort of put all our artifacts in there or like whatever, but like maybe just to make this a little bit cleaner, let's put this in the deps folder just to sort of keep it tucked away there. Let's just see if that works. Okay, there we go. That's sort of what I wanted. Okay, so we've got our deps.o folder there. If we haven't even checked this into Git, which I will do, but once we did that, we'd add that to our git ignore folder. We want to ignore all the object files. But let's generate that object file. I still thought this would work. Let me just add this back here. Not sure why there. Yeah, there's something I'm doing here that's just not quite right because I really want these to be a dependency of that. Dry, so we can do a dry run to see what it's. It's saying there's no target, but they're not targets, these are files. So I don't know what I'm missing there. What am I missing? Am I spelt it wrong? Have I? Yeah, anyway, I'm not going to worry about that for now. So we'll continue on. But yeah, this is generating a depth silo. Okay, now back on our demo app, we just now need to include that object file deps.o into our build. Okay, deps.o. Okay, so now when we build our demo app, we're including our dependencies. Okay, so make run, and I didn't spell that right. And there we go, we've got it. Okay, cool. So now though, when we build our dependencies, that is the slow part, right? But now if I make a change, it's going to be hard to see the difference because this is compiling quite quickly anyway. But if I save this file and we hit make run, it's almost instant, right? Like the compile time to compile the main.c is so quick. And even if we add more and more dependencies and the library gets bigger and bigger, because if we look at the Sokol app, there's, we might include the audio, we might include the fetch, we might include the log and some time. So we could include these other functions, there's other libraries that we might be including, and all that's going to add to the build time, right? So we don't want to be building dependency code every single time when it's not changing, right? We only want to be building this main function that's changing all the time, right? As we're sort of developing. So now I can hit make run and bang, well, that wasn't a good example, but if I save that file, make run, it builds it. And we're not rebuilding the object file because it's now dependent in the pipeline. So yeah, and yeah, this would be what I'd like to actually depend on. I'd like this make file to depend on these ones. So then if I run an update, which I've got an update function down the bottom where I go and refetch the latest versions, I would like this to then, only then when these files get updated, to rebuild this. So I would like this to get included into this, but I'm just missing something I can't quite think of. So if I think of it, I will put it in another video. But anyway, for now, that's all I've got. So see you next time. Oh, I'm back. Now I've figured out what it was. So yeah, before I was trying to include depths, and you've probably all seen it, depths like this, and getting an error, and the error is because I cannot spell Sokol. And if I now run it, there it is. So now if I, yeah, this is now a dependency of these depths. So if I run this, get this fetch function down the bottom here where I'll fetch Sokol, make Sokol, that will fetch in the latest versions. Okay. Now I make run. There we go. So you can see there, the first step there is actually rebuilds the dependencies because they've been updated, and then it will rebuild the rest of that. And then if I run that again, it will just run it. But this time, if I only edit the main file, it will only regenerate the main file, not the not the main file. So there it is.